So my name is Matthias Noback. I used to travel many times to Barcelona for some events years ago, like Symphony Catalunya and PHP Barcelona, and maybe you've seen me there. At least I recognize some faces, so it's nice to see some of you back. Happy to be here and talking about hexagonal architecture. It's just if I see the word hexagonal, I'm just getting excited already. So I noticed with your slides just now. Thanks for an excellent talk, by the way. We agreed that Carlos would talk about the general story about hexagonal architecture, and I would just add something about testing. And actually, it's a bit funny because you can do hexagonal and do no testing at all, even though hexagonal architecture is explicitly designed to be helpful for testing applications. So that's just an interesting way of turning things around. But when you apply these ideas, you get a very excellent setup for testing. And I just want to show you some ideas that you could apply together with hexagonal architecture, or even with just layering. You get some of the same advantages, I think, as you explained as well. I'm a PHP developer mostly, but I'm also doing training and conference talks. Like not now, but just now, I'm also wearing a hoodie, right? So I'm part of the the culture of being a programmer, even though I also like to talk publicly, which is maybe not for everyone. Well, I realize that. All right, so you can reach me on Twitter if you want to talk with me about any of these topics. Feel free to reach out at any time. I'm always happy to discuss these kinds of topics. First, let's get back to something that Michael Feathers wrote quite some time ago on a blog. He says, a test is not a unit test if it talks to the database, it communicates across the network, it touches the file system, it can't run at the same time as any of your other unit tests, or you have to do special things to your environment, such as editing config files to run it. Very interesting, and I think there are actually more aspects to it, like touching the file system, making network connections are examples of a more general thing where you reach outside of your application for some piece of information or to perform some kind of action. And really this is the same thing as we just called infrastructure code. It's about talking to the world outside. So unit tests, it turns out, have a lot to do with what hexagonal architecture is aiming for. So once we have this distinction in mind, we keep this in mind, there are things we can write unit tests for and other things we can't write unit tests for, or when we do, they aren't really unit tests. You know, we can run them with PHP unit or whatever JUnit, XUnit test runner you use, but it won't really count as a unit test. Keep that in mind, and you will develop better applications, I'm sure. Some of the properties that you get from this list of characteristics once you follow these rules are these. So a unit test is deterministic. When you run it, the result will always be the same given the input, right? It's also going to be very fast. It doesn't need any special setup, as the definition said. It doesn't need a database, a network connection. It doesn't need the other service to be up and running, since we will never call it. So that's a good thing to have there. And since it's very close to the unit that it is going to test, any kind of trouble that is going on there in that unit, anything that is causing a bug or producing unexpected behavior, is right there, right in your face. When it's wrong, you will see it, and you will know that the source of the issue is very close to where you are now. You are looking at the problem. So that's a very convenient thing for tests, because you are trying to uncover problems, and as closer you are to the problem, the faster you are solving it, and the better you know what's going on. What is the relation with hexagonal architecture anyway? So we're talking about unit tests, and this is about like application design. Well, hexagonal architecture automatically allows you to test bigger parts of your application in the unit testing way. And this is the consequence of always separating domain from infrastructure concerns. If you do this, you get sort of unit testable most of your domain code. And the other parts, well, they aren't unit testable, we will talk about that, but at least you will keep pushing more towards the unit testable code part of your application. Because as soon as you separate domain code from infrastructure code, if you mainly, like basically keep separating pure code from infrastructure code, just plain manipulations of data and your knowledge about this data around it, then you get automatic and guaranteed increase of testability. It's almost like it doesn't even have to be explained, because as soon as you leave out infrastructural details, you don't talk to any database or file system or across a network at all, then you have testable code, because now this code can be influenced in any way you like in a test scenario, and there won't be other influences on the outcome of the behavior that you're testing. So that's a very cool property of writing this kind of code. Another thing about hexagonal architecture, like the benefit number 2, you could say, well, depending on your preference, maybe it's benefit number 1, is explicitly designed use cases. So anything you can do with your application is right there, modeled as a single class or maybe as an interface, and it's clear what this use case is, and it's modeled completely separated from its infrastructural connections to the world outside. Because a port, I'm not sure if we use the same words there, but a port is an intention of communication. Some communication is going to go on here between something in the world outside and our application. So it can be either something that is talking to us, or that we need to talk to something else that is outside our application, and now we have a need for communication. So yeah, I use these words sometimes, like it can be an intention from a user who wants to talk to us, but it can also be a need where we need something from some other external thing. And an adapter contains the supporting technology for that communication. So it's any kind of implementation detail that we need to have in place before we can actually make this communication and during that communication. Yeah, and as I mentioned, there can be different types of ports. Well, I think the driver port was a nice name. Alistair also calls this actors. Like actors are talking with our application. Primary actors are initiating contact, and secondary actors are acted upon. So we talk to these actors. So the secondary actors could be databases or other services or queuing systems or email servers, things like that. And incoming doesn't necessarily have to be users. It's anything else that is talking to us and wants us to do something or wants us to show something. That is an option as well. So combining these two qualities, where we have a separation between the use cases and their implementation, as well as a strict separation between domain code and infrastructure code, we now get a very nice thing. We can test our use cases, or most of our use cases, using these very fast tests, which are much closer to unit tests than to any other kind of test. At least they follow the kind of definition of a unit test, where all of these characteristics that we mentioned in the beginning are true about most of the code, or actually all the code that is living inside the hexagon. So that's a very interesting thing. We can now not only write unit tests for our units, but we can also write unit-like tests for our application as a whole, for the use case as a unit. Pretty interesting. So an example of how you would separate these things like domain and infrastructure, these are use cases for like a meetup application, where you create a group for meetups. Then you start scheduling a particular meetup, like tonight's meetup. Then you accept registrations, or RSVPs as they might call it. You may want to see the upcoming and the past meetups. You want to browse through the history and make plans for joining potential upcoming meetups. You want to then look at the details of the talk and the organizers and the speakers, and all of that is to be considered use cases. Like what has the application to offer to its users in terms of the actions they can do or the information they can retrieve. This doesn't really talk about the secondary actors, but of course we also need ways to sort of remember the meetups that we scheduled, because the next time we go to the website, we still want to see the same meetups. It shouldn't have forgotten about them or something. So these are actual needs for the application to fulfill their use cases. But there is no infrastructure in this. We can talk about all of the use cases without actually mentioning technology that we need or any kind of setup or a particular type of web server we want to use. None of that. So there is no framework. We don't even talk about do we use Symfony or Laravel. That's an irrelevant discussion at this point. We're just talking about what should our application be capable of doing. Very, very important distinction. We don't talk about controllers or what they look like. Do we use PSR7 or not? We don't talk about a database, not even the technology that we use there. Is it a relational or a document database? We don't actually care. We only think in terms of, well, eventually we will need to store something, but it's more like we saw before, like we need a repository. We need something to put this thing. We don't worry about the infrastructural details yet. We don't think about external services. Do we use a payment provider? Well, some payment provider, but well, we don't make a decision yet which one that should be. In fact, none of our use cases should be affected by which exact payment provider we are going to pick later on. No file system, no clock. We don't ask for the current time. We don't ask for random data. We just fake some data whenever we need it. And we should be fine for a very, very long time. Yeah, if you look at this hexagon structure, you could say that indeed there are different entry points to the application. These could be considered the ports. Like the inner hexagon, or maybe just the hexagon, is the one that contains the domain code, the unit testable code. And then the outer thing here, that could be considered the adapter layer. It contains all of the code that is needed to facilitate that communication from outside to the inside and back to the outside again. So as you can imagine, we can have unit tests for anything that is here, like an application service or a domain object. I didn't put a block for that here, but you can imagine like maybe an entity there. A repository interface is not really unit testable. There's nothing to unit test. But any code in here doesn't really use any infrastructure code. So it doesn't run any database query or try to store a file or send an email, nothing like that. If anything it needs from the world outside, it will use an interface like this one. If there is a need, it will talk to an interface. And well, the core code or the domain code doesn't really worry about how is that really implemented eventually. So basically you can just evoke that code or invoke that code, run that code that is inside of the hexagon. And this is why I have this yellow block here, the test driver. It can just start calling that code and see what it does. What are the effects it produces? Does it work nicely together within a use case or across use cases? You can imagine at some point, if you have many RSVPs for a meetup, there should be some signal to users who still sign up saying, oh, well, we are full. You know, that's the kind of thing that could happen in the real world. So we need to have like a relation between these use cases. And we can all still test that just by using unit test-like tests that don't invoke any infrastructure, are fast, deterministic, and will tell us what is wrong very close to where it's wrong, where it happens. But yeah, I think the problem here is that if we have a test driver which calls, say, an application service, and we have, well, once it needs to store an entity, we use a repository and we have a replacement, also known as a stub for that, then we can't be certain that this actually works. This web controller might do, well, weird stuff that is not corresponding to the way that our application service expects to be called. Or, in fact, our repository may be used in ways that a MySQL database doesn't really support. So there is a testing gap there. We don't have tests showing that our adapters really work well. So this is something that is left to do for us. We need to prove that the port adapters implement the contracts provided by their interfaces correctly. So they can be used as indeed as the same effective replacement for the stub as the real thing. These tests could be called adapter tests. You could also say integration tests. This is a specific terminology. I know integration test means different things for different people, but well, in my book it's called that. I am writing a book about that, so it's a coincidence, but I love this stuff so much that I will publish next year a book about layer sports adapters, separating infrastructure from core, but more about that if you look me up on Twitter. Integration tests, they do the actual work. So they want to prove that the MySQL adapter for communication, like storing our meetup entity, is actually able to talk to a database and store some data in a meetups table. So we test the repository against the actual database. We don't use an SQLite replacement there. We just want to have the actual database that we're also going to use in production. Like maybe not the actual database, but at least the same technology and the same configuration to prove that our ideas about it are correct, our assumptions are correct, and our code is able to communicate effectively with that actual database. When we make an integration over HTTP with some other service, this is the place where we actually test that integration. We make an HTTP call, we check if we understand the response. We also test for failures. We try to make a bad request. Can we deal with that? We fake a bad response. Can we deal with that? All kinds of things there that we need to show that we have our adapter and it works correctly according to the contract that it has based on the port it has, or it's an adapter for. We also may test an application service using a real web controller, and this is, well, we're not really going to test the application service again because we have already tests for that on the level of the Hexagon, but the integration test may prove that given an actual request, we can convert that to a message that is going to be understood by an application service. What I find very useful there is to show that the adapter works and it eventually will create a command object, if you use commands and command handlers, that it can show, or that it can produce a command object that is then understandable by the inside of the application. So that's where I think a command bus is a very useful thing. Even though last year I thought it was a very bad idea, but now I'm like, okay, no, that can work, it can work. It can be the interface that represents this port, basically. Yeah, and on the other end, we may want to test the MySQL adapter, which implements this repository, but now we say that, like, we don't even look so much at the repository, more we test, does this thing work? Does it talk to the database correctly? Does it deal with failures there? Does it interpret its response correctly? And this means that you might involve all kinds of infrastructural things, like an actual database, but also maybe PDO if you use PHP, or doctrine connection object, or whatever kind of technology that is between you and that database. You still want to invoke all of it just to prove that you understand it correctly. In particular, if you use doctrine ORM, I find this a very useful thing to do, because it's very easy to misunderstand doctrine ORM, to have mistakes in your configuration or make bad assumptions about what it means to persist and flush, well, things like that. So in particular there, it's very useful to test in isolation your repository. Does it deal well with an actual database? So just a nice recommendation. What is missing? Like, we have unit tests for our domain model. We have these sort of unit-like tests for our entire Hexagon. We have adapter tests for the adapters. We can prove with integration tests that they are implemented correctly according to the contracts they specify or they implement. And now what's missing is a way to be sure that the deployable unit is going to work correctly, because there are always differences between how the application looks in a test environment and how it looks in a production environment. So what do? We create a hexagon that is sort of wrapped, everything is inside. We don't even know that much about what is inside. We only talk to it. And we have to set up some kind of technologies surrounding it. Like the logos, they are behind the hexagon in this case. That doesn't really mean anything. It is because this logo has no transparent background. So you would have a white box here. That's a nice detail maybe that you should know about. But it's good to know that we don't care about the inside of the hexagon. We care about can we talk to it. So we need a web server. But we also want to know, can it talk to our database? Can it talk to our queue or whatever stream stuff we use? And this is going to be as close as possible to the real thing. And it should help us see if we have not made any configuration mistakes or like last-minute wiring mistakes. It's almost like a smoke test for your application. You don't test much through this kind of testing style. You basically test maybe one happy path to show that the most important flow through the application works. And that could be the flow that makes the most money or is the most important in terms of user experience or whatever. Could be your decision there. Yeah. So combined, we now have different types of tests. I didn't mention acceptance as the name for that, like a hexagon test or like inside of the hexagon test, but you could call it acceptance. This follows the naming convention of the book Growing Object-Oriented Software Guided by Tests, if you're interested in that. They use this kind of distinction. I find it very useful. So you have unit tests for the units in your code that can be unit tested. You may have acceptance tests that show that the use cases are implemented correctly. And this means like it's acceptance because it shows that you have done or your application does what will be accepted by its stakeholders. The application does what it's supposed to be doing, except it doesn't really talk about technology yet, and this is where you need the integration test. You need to show that the technological decisions that you make are correct, and your assumptions about the technologies that you use are also correct. So this is something you prove with the integration. And then finally, you prove that the deployable unit is also functioning correctly, and you won't get any bad surprises when it's in production. Well, of course, you will get bad surprises when it's in production, but at least you have done all you can to prevent the most stupid mistakes there. All right. So when you are building confidence using all these different kinds of tests, you have an ability to catch bugs early where they are. The more you can unit test, the more you can acceptance test, the earlier you will find any core like business logic mistakes. So you will find them there. An integration test will show you that you made some mistakes in the assumptions about how does doctrine work, how does my database work, what kind of configuration does it need. So any kind of problem there is also close to the source since you're only testing that particular adapter. Compare this to how a system test would show you a problem. If that would be, maybe that could be a domain, like a domain logic thing. It could be a vendor library thing. You don't know. You have to dive really deep if a high-level test fails. Now with these different types of tests, you get early feedback and very close to where the problem is. Another awesome thing here is that you can postpone infrastructure decisions. You can work on the hexagon for quite a long time without even making a decision like what database technology am I going to use. It's actually completely irrelevant as long as you can show that you understand the domain logic, you have implemented the right scenarios, your use cases do what they are supposed to do and can help the users with what they are trying to achieve with their application, with your application. And talking about scenarios, you can use these both as a testing tool. You can run scenarios with some tools like Behat or Cucumber, if you maybe know something like that, where you can make these descriptions of what should the application be capable of. You can make these descriptions executable and then turn them basically into tests showing that you have a correct understanding of the application. And then you can talk with domain experts or other people who are interested in your application, and you can show what it's capable of. Like in theory, of course, you still need to implement the adapters and show that it actually works with technology. But yeah, as long as you are doing that, you don't really have to worry about the framework that you're going to use, because these scenarios can run against the hexagon itself. It doesn't need all of that infrastructural stuff around it. I know a few teams who have been working like this, including myself, on a recent side project. So no adapters, just ports, just acceptance tests showing that, yeah, my understanding of the domain is correct. Everything can work. We only need to have these adapters. And it can take weeks before you start writing your first web controller, for example, or when you first create your first table. Yeah, it's just really relevant for architects to be able to postpone these kinds of decisions instead of like going for MongoDB in sprint 0 and realizing that it's a really bad choice a couple of weeks later. Not saying that MongoDB is bad per se, but just that you need more input to make these kind of decisions. All right, so that's it for me. As I mentioned, you can reach out on Twitter, and if you like, we can also have some questions now. Yeah, here is a mic for anyone who wants to take it. I won't throw it. No questions? Okay. Yeah.
Just for the sake.
Thanks very much.
Thank you.
Yeah.
My question is about integration testing. For example, you want to test that something is safe to MySQL through a doctrine repository. Do you assert that the creation was good, or do you do a find of the entity and then check that it exists?
Yeah.
Like the best practice, or
Yeah. So the question. Oh, I don't actually have to repeat it. I think because you probably all heard it. What you test if you do an integration test for a doctrine repository. I would focus as much as possible on what the contract says it does. So the contract for a repository will be, you can get an entity by its ID, and you can save it, just save the whole entity. And what is a good test for that? Luckily, they are symmetrical. So we can first create an entity, save it, and then get the entity by its ID, and we should get the same entity. Well, maybe not the same object, but at least it should be comparable. And this is how I would approach it. I would say, create the entity, save it, then get it by its ID, and store that value into a new variable, and say assert equals, yeah, it worked. But then you may have issues where child entities have been defined, or there are specific value objects that are only available after certain actions. So what I usually do is create some variation. I create a basic entity, I make some changes, I add some child entities here and there, and try to save and get them as well. So that helps you to test the actual mapping. Sometimes if I'm worried that maybe child entities are becoming orphan objects in the database, then I do an extra check. I go into the database itself and see if the table doesn't contain other things that shouldn't be there. But usually I just trust the basic mapping there. Okay, thank you. All right, any other questions? Yeah, let me, oh, I can walk over there. Yeah.
In the integration test for the web controller to the side Hexagonal, you mentioned the command bus.
Great.
You mentioned the command bus, so the assertion will be that you are dropping the right command on the command bus, so you have kind of changed something in the bus configuration, right? Because you don't want to trigger all the logic that goes inside.
That's right. Yeah. For an yeah.
Question.
Awesome. Yeah. So for different kinds of scenarios, I would replace the command bus and the event dispatcher, so that no extra logic will be triggered. It's just about that point where you want to be sure that the right command is being created, or that the right events are being dispatched, but I don't want to check the whole handling of those events. So command bus and event dispatcher are more somewhat of the same kind of object, where it's just about forwarding the call to something else within the hexagon. Yeah, and I don't want to test everything that's going on in the hexagon. I just want to test the adapter. Yeah, I had a recent example where I was creating an application, still creating it, that receives commands from an email. So the IMAP, like it's a mailbox, I connect to it, and I accept commands from email, and then the adapter converts the email to a command object, and I just check if that command object looks what I expect. from the email itself. Yeah, special case of an adapter, I think. Yeah. All right. Yeah.
Hello. I have one question related with the, let's say, performance test, which I never understand how to, for me are technical tests, but at the end are acceptance tests. So at the same time, it's like something that for our product, let's say, is important, but at the same time for be performant and be something that we should make. So I don't know how to handle this in terms of hexagonal and how to, let's say, categorize this.
Yeah, I think there's a distinction. These tests that I mentioned are functional tests. So each of them shows that the application functions correctly. But there are usually other criteria. You could have security issues maybe that you want to cover for sure. You have performance tests that you want to run. These are, I think they are called non-functional tests actually. But you should still run them alongside with your tests because they are equally part of what on a larger level stakeholders would consider acceptance criteria. So not everything about acceptance criteria is about functional criteria. It's also about these special cases. And it could be like we want to have zero downtime, or we want to be able to accept like 1 million requests per hour or something. Yeah, I don't have particular advice coming from the hexagonal like design style or something. Except that probably if high performance is an issue, you may want to make some changes here and there that maybe are not as pure hexagonal as you might hope, just because you have performance issues. Just like frameworks don't write or don't have the best code out there because they just need to write bad code for performance sometimes. Okay. Yeah. I see no other hands, so I think that's it. Thank you, and have a good night. Thank you.